1, and when you cross multiply, one side goes away. But it's not the only method. So if you want to go ahead with that, then you will have this as the first step, right? Yes? Okay, then I would have to write two restrictions. So I don't forget, because if at the end of the day, if I get x equals 3 or negative 3, I will have to say no way. Okay. Then you will find the least common denominator. Not difficult because I only have 2 and they both have power 1, so this must be x minus 3 and x plus 3. Agreed? Okay, so then I need specific adjustments. This one has x minus 3, but it does not have x plus 3. This one has x plus 3, but it does not have x minus 3. And this one has both, so it doesn't need anything. By anything, I mean 1. You don't have to write that one, though. Then I distribute 2 to 2 terms, and I get 2x plus 6. Agreed? Then I distribute negative 4 to 2 terms, and negative 4x and plus 12. And then minus 8. Then I combine my terms. And I get negative 2x. And this is 18 minus 8, so this is positive 10 divided by x minus 3 and x plus 3. And this is 0 over 1. That simplifies a lot. And then when I cross multiply, because now this is a proportion, I get negative 2x plus 10 equals 0, or x equals 5. And 5 is not on the list of restrictions. It's not 3 or negative 3, so it should be safe. Should we work on another or complex rational expressions? Say it again. Complex. Very good. So let's look at 74 on page 5 of 7. 74. 3 divided by x minus 1. Minus 2 divided by 1 minus x. 2 over x minus 1 minus 2 over x. It's not a really friendly situation. So let's work on this for a minute. Are we ready? Or not yet? Okay, can anyone tell us what we should do first? When we look at the denominator, I'll say it's okay. But when I look at the numerator, I don't say it's okay. Why? Right. So this is a problem here. So I have to reverse, put them in a descending order. So this is 3 over x minus 1 minus 2 over negative x plus 1. I still don't like it. But now in the denominator, I can find the LCD. And the numerator can wait. I'll get back to it. So what is the least common denominator in the denominator? Very good. Two different factors, nothing in common, power 1, that's it. So what does this need? What does this need? This one needs x, and this one needs x minus 1. So what will you tell me to write up here? Very good. Minus 2x plus 2. Do you all agree with 2x minus 2x plus 2? Yes? Okay. So I see that these two go away. So I can already write the denominator as 2 over x times x minus 1. But I still have a lot of work to do for the numerator. So the numerator is 3 over x minus 1 minus 2, and now I factor out negative 1 and write this. Of course, I will write that x cannot be 0 and x cannot be 1, so far, anyway. But now I have to simplify this. This one is a positive number. This one is a negative number. So the outcome of this fraction is negative, but there is a minus in front. So positive over negative is negative, but there is a minus in front. So what will I write for the numerator? I will write 3 plus 2 over x minus 1. I get the same denominator, and this is 3 but plus 2. Positive over negative is negative, with minus in front is positive. So the numerator is 5 over x minus 1. The denominator is 2 over x times x minus 1. So all this effort was to have in the numerator just one fraction and to have or change the denominator into one fraction. And now I know how to divide these two. I copy the top. And what do I do with the denominator? Yes. So it's x minus 1 divided by 2. I already stated my restriction, so I'm safe. This new denominator does not bring an additional restriction because it's 2. It doesn't have x in it. So then what goes away? Because there is something that goes away. Indeed. So what is the simplified form assuming these conditions are fulfilled? That's it. Awesome. That was not a pleasant situation. Would you like to continue reviewing chapter 7, or can I go back to other chapters from before? This was 7.7 that we just did. Okay. This is it. We can do one more in 7.7. Let's do that. 94. Very good. 4 plus x to negative 1 over 3 plus x to negative 1. Okay, 1 minute. Can anyone just dictate the first step? What would you write?
4 plus 1.
That's it. And the denominator. Awesome. Then you will find the least common denominator in the numerator and the least common denominator in the denominator, and you will only have to state one restriction, which is correct. It turns out that both top and bottom have the same LCD, and the adjustments are the same, bless you, for both. So this is 4 plus 1. I meant for x plus 1 and 3x plus 1. Any questions so far? I copy the top, I flip the denominator, and change the division into a product. However, I have an additional denominator that needs to be restricted as well. So I have to add one more here, negative 1/3. And then I'm ready to simplify, and I simplify x by x, and I want to simplify this x with this x. Absolutely not. That would be a terrible mistake. Good. Do we continue with the chapter 7, or can I choose other problems for review for the final exam?
Okay.
Say it again.
Okay. Other problems.
From chapter 7? Oh, other chapters.
Yes.
Okay, so we're done with the review for test 4. Is there anything that you would still have questions about and you would like to go back and review from chapter 7 or chapter 12?
In the, this isn't about the test, but the gradings, you know, here is different than random. So how is it like where
You mean the overall, the level
Yeah.
grade?
yeah.
So it's mentioned in the syllabus, but what I'm doing is I would replace the lowest test grade by the final exam grade. So if a student missed a test, for example, that test will be replaced. If a student gets 100% on the final exam, then I will replace the 0 with 100%. So, and no one has to remind me of that. I will do it before I turn in the letter grades.
But for like let's say for so like if you have an A, you have 15 to 90.
Right. Yes, that's a very good question. So if a student has an F on the final exam, I will not curve that grade
Where does it have?
on the final exam.
No, like where does it start at? Because it's different than
She's asking for the first
50 or
overall.
below,
Yes, that's mentioned. So
and like anything below like 62.
so is it 60 and below?
yes.
Okay, that's 69.
Oh, really? No. So in general, so what I'm saying is that if a student has, let's say, 78%, and the student failed the test, the final exam, I would be very reluctant to move the grade from a C to a B. But if the student has at least a C on the final exam, and even if the student gets a 75% overall, I will move the grade to a B. I will. Because if a student gets such a good grade on the final exam, I'm hoping that the student will learn something in this class.
I was just comparing the scale, I guess, to
Right.
lines.
Okay, so it's more stringent, more
Yes, you know, which I think it would
which is
Texas, yeah. I didn't think it would be
okay.
different.
Okay, so let's go back and review other things then. Our previous test was on chapter 11. So quadratic functions. So that was chapter 11. So let's go back. And here are the topics. Equations quadratic in form, quadratic and polynomial inequalities, word problems, graphing, and 4 methods of solving quadratic equations. One more time. Graphing quadratic functions, solving quadratic equations with 4 different methods, word problems, solving equations quadratic in form, and solving inequalities that are not linear, quadratic or polynomial, and word problems. Okay, I will choose. So let's say 68 on page 709, 2x minus 3, 4x plus 5, greater than or equal to 0, and I want to add one more, so I'm just improving it. So this is really no longer 68 on 709 because I added something else in there. Okay, so we're asked to solve this inequality. What do I have to do? How do I solve this inequality? Remember, the chart that we used requires a 0 on one side and a product on the other, or a ratio of factors. We have that. I have a product on one side and I have 0 on the other. So I can start the chart. X is the variable in the problem and it can be anything. I have a factor called negative x plus 3, a factor 2x minus 3, and a factor 4x plus 5. And since you know me, I always run out of room, I'll say the product. Instead of putting the whole thing in there, because I don't have enough room, I just wrote product. Yes? I'm sorry? The product, this whole thing, all of it in here. But I used the word product because I didn't have enough room. Yes. Good. So what numbers go in the chart? What number goes in the chart for the first one? It's 3. Very good. So let's write them aside before we decide which is the correct order. Good. So 3 comes from the first one. What about the second one? From the second one is 3 halves. 3 halves. 2x minus 3 equals 0 means x equals 3 halves. And the last one? Good. So then which one will be the first? From left to right. Very good. The next one? 3 halves. And the last one?
3.
Yes. Remember, they have to be in ascending order. Awesome. So now each factor has a 0 somewhere. The first one has a 0 under. Awesome. The next one has a 0 under. Awesome. And the last one has a 0 under 4x. The 4x plus 5 has a 0, of course, under the last one. Now I have to see and identify what happens to the product in each of these 3 situations. So under negative 5/4, what is the product equal to? What does it equal to? 0, right? And under 3 halves. And under 3. Awesome. Now remember, you can plug in a number between negative infinity and its 0 and after, but there is no need. These 2 functions look like this. These 2, with the positive leading coefficient, positive slope. This one looks like this, which means this one comes from negative and goes to positive. From negative, then it's 0, then it's positive. negative, then it's 0, then it's positive. But the first one, because it has a negative leading coefficient, it will do this. We'll come from positive and go to negative. So positive and negative. Now I only need to establish the sign for the product in each subinterval. All I'm counting is negatives. When I multiply or divide to negatives, what sign do I get? Awesome. And in the next subinterval, I only have one negative, so there is no discussion there. On the next one, I don't have any negatives. Again, there is no discussion. And in the last one, I have one negative, which makes it negative. Now I'm ready to look here, only now, because now I'm ready to choose the answer. I'm looking at this. What is greater than or equal to 0? There is only one sign that is greater than or equal to 0, and that must be positive. Is the product ever positive?
Yes.
It's here and here, which means the solution is this union this, because I have to give the answer in x. So x in the interval, what would you say? Negative infinity, comma. Very good. I have to choose the bracket because the equal symbol here. Union
3.5.
with a bracket, yes, 3/2, comma.
3.
That's it. Awesome. Good. So let's look at equations quadratic in form. Ready? About 22. But they may have part A, part B, part C. Yes. But normally it's not a long test. You should be able to finish in about an hour and a half. I don't recommend it because this is very important for your final grade. But about an hour and a half. Okay, equations quadratic in form. Okay, problem 10 on page 709. Although this one doesn't really require a substitution, I recommend it. Let's see what we get. 709. So let's work on this problem. I recommend the substitution. It's an important method. And when you get used to it, you will be happy with it. Should we review completing the square? Okay. Yes, that's perfect. This you don't have to factor if you don't want to. If you can say, okay, I'd rather use the quadratic formula, but use any method you like to get that, to get t. Although it's not difficult to factor. So, but if you have any difficulties with factoring, you can use the quadratic formula. So we let t be x plus 1. And then the equation becomes Awesome. Now let's see if it takes more than a few seconds to go factor. If it takes more than a few seconds to factor, then use the quadratic formula. So is there a way of factoring this?
X minus 7, X minus 8.
Yes, t minus 7, t minus 8.
What's the quadratic formula again?
Negative b plus or minus the square root of b squared minus 4ac over 2a. We cannot use x if you use the substitution.
I was just looking.
That's fine. Yes, sure. So then t equals 7 and t equals 8. However, these two give us two new equations. What are those equations? One equation is x plus 1 equals 7. The other equation is x plus 1 equals 8. So then x equals 6 and x equals 7. Okay, let's complete the square. Let's say x squared minus 10x plus 2 equals 0. Let's complete the square. Let's solve this equation by complete the square. Let's refresh our memory on the method. So what is the first step? Identify the middle coefficient, which is awesome. Then awesome. Then awesome. Then that's it. Add 25 to both sides. Awesome. So then I have to write that x squared minus 10x plus 25, I will move 2 to the other side, equals 25 minus 2. So I have to add 25 to both sides and move 2 to the other side. And the left-hand side is our first agreement, 3 months and a half ago. Very good. X minus 5, everything squared. That's why I put it there. And the right-hand side is 23. As I mentioned many times before, maybe too many times, complete the square does not solve the equation. After all this effort, I can't solve unless I remember what to do next. And what I have to remember is to take the square root from both sides. But I also have to remember that this is quadratic. And it must have how many solutions? 2. And those 2 solutions will come from x minus 5 equals, it should be the absolute value. Instead, plus or minus the square root of 23. And I have to move 5. Careful. 5 has to be moved between the equal symbol and plus or minus. Say it again. Yes. Okay. Okay. Let's take a look a little bit at chapter 10. Chapter 10 was big, right? Dealing with radicals. So let's take a look at finding the distance and the midpoint. Okay, so let's say we're given 77 on page 646. We're given two ordered pairs, -1, 5, and 2, -3. We want to find the distance and the coordinates of the midpoint. Distance and the coordinates of the midpoint. Does anyone remember the distance formula?
Square.
Awesome. The difference of x's squared plus symmetric, yes, the difference of y's squared. And remember, you cannot have a negative number, right? This is something squared, which will always be positive. This is something squared, which will always be positive. And positive plus positive cannot be the square root of -5, right? So let's plug them in. Yes. So x2 is this, 2. x1 is this, -1. y2 is this, and y1 is this. So then d equals, let's do this together. 2 minus -1, how much is that? 3. And 3 squared is 9, plus. -3 minus 5, -8 squared. Very good. So then d equals the square root of 73. And no one can simplify that. Now let's find the midpoint. Remember, the midpoint, the coordinates are the average. Add them up and divide by 2. And then add them up and divide by 2. So add the x's up, of course taking care of their signs. So I'm adding 2 to -1 and I get 1. And I have to average that. Divide by 2. And then I'm adding 5 to -3. What do I get? 2 divided by 2, 1. The average of x's and the average of y's. x1 plus x2 over 2, y1 plus y2 over 2. Average of x's, comma, average of y's. Okay, let's look at multiplying two complex numbers. Problem 136 on page 647. 3 plus 2i times 1 plus I. Let's multiply these two. Page 130, page 640, say again? Two complex numbers. It's the same with foiling. When we multiply two complex numbers, that's all we do. So, can anyone dictate?
3 plus 3i
Excellent. Plus.
2i plus 2i squared.
Very good. What do we know about I squared? Awesome. So then we have 3, but since 2 times -1 is -2, 3 minus 2 is 1 plus,
5.
that's it. 136 on page 647. Let's look at the absolute value inequality. Like 26. Then we can stop. 26 on page 582. 5x minus 3 in absolute value greater than 2. Let's think about this for 1 minute. Can anyone tell us what to write, what to do here? Say it again. I cannot do that.
5x minus 3 is greater than or less than 2. And then 5x minus 3 is less than or greater to negative 2.
Just less than negative 2. Awesome. Because this is a situation in which we are trying to determine this. Because it's greater than 2. Further away from 0. More than 2 units. So then the first one I add 3. So I have 5x greater than 5, which means x greater than 1. And for the other one I have 5x less than 1, which means x less than 1/2. This particular type has to have the union between the solutions. So x in the interval. And I have to start with the appropriate one first. It's not a mistake, but I have to start with the correct one first.
What do we want over 5? 50?
Oh, yeah, yes, I'm sorry. I looked here and I wrote 5 instead of 2. No excuse. Sorry. Thank you. So, the first one.
Negative
Negative infinity. Awesome.
2.
1/5. Parenthesis or bracket.
Just parentheses.
Union.
Parentheses, 1, parentheses.
That's it. Any questions?